Section 10.1 is on square root functions. A square root function is a function that is in the form y equals the square root of x. Notice that x cannot be a negative number because x is underneath the square root sign, and we can't take the square root of a negative number. Therefore, the domain of this, the values of x that will work, are all the values of x such that x is greater than or equal to 0. In other words, x has to be 0 or any number greater than that. Let's take a look at an example. This is actually the parent graph. We're going to graph y equals the square root of x. So I'm going to make a table of values, and since x can't be a negative number, I'm going to start with x equals 0. So when x is 0, the square root of 0 is 0. Now for the rest of my x values, I'm going to pick only values of x that I can actually take the square root of. You can use your calculator and come up with decimals, but that's just too difficult. So I know that I can take the square root of 1. So when x is 1, the square root of 1 is 1. Next number I'm going to choose is 4, because I know that the square root of 4 is 2. And I'm going to choose x equals 9, because I know the square root of 9 is 3. I could continue and choose 16, 25, 36, but those aren't going to fit on my graph. So let's just stick with these numbers right here. So here's the point 0, 0, 1, 1, 4, 2, and the point 9, 3. So the graph is going to look like this. And this is basically what all square root function graphs are going to look like. They'll have a starting point, and then they will kind of swoop off to the right in this direction. Now, they can be wider or narrower, they can be below the x-axis, and they can be moved left, right, up, or down. We'll take a look at that in just a minute. But this is the parent graph of a square root function. Y equals the square root of x. So the radicand, that is the stuff that's underneath the square root sign, can be something other than x. It can have stuff added, subtracted, multiplied underneath the square root sign. The full form of the square root function is y equals a times the square root of x minus h plus k, where a is a number that's out in front of the square root sign being multiplied by the square root. H is a number underneath the radical sign, which is being subtracted from x, and k is a number that is added on the outside. The vertex, or the starting point of our graph, is going to be at the coordinates h, comma, k. So in other words, whatever h is, that's going to be the x of your vertex. Whatever k is, that's going to be the y of your vertex. And notice up here when we did the parent graph of the square root function, I didn't have anything subtracted underneath the radical, and I didn't have anything added out front, so my h is 0, my k is 0, and indeed that was my starting point, or my vertex. Now, as I said before, the graph can change a little bit. If a is greater than 0, the graph is going to be above the x-axis. If a is less than 0, that is, if a is a negative number, the graph is going to be below the x-axis. It's going to be reflected over the x-axis and be down below it. If h is greater than 0, then the graph is going to be shifted h units to the right. If h is less than 0, if h is a negative number, then the graph is going to be shifted the absolute value of h units to the left. If k is greater than 0, the graph is going to be shifted k units up. And if k is less than 0, the graph is going to be shifted the absolute value of k units down. So let's take a look at a couple examples here. Directions say graph each function and then state the domain and the range. So our first one is y equals negative 2 times the square root of x. Notice that this is the same as negative 2 times the square root of x minus 0 plus 0. Remember, this is my h, and this is my k. So my vertex, or my starting point for this graph, is going to be the point 0, 0. And that's really helpful because that's where I'm going to start my table at. So let's make a table of values. And I'm going to start with the point 0, 0. And as we did with the parent graph, I want to choose values of x that are going to make the stuff underneath the radical something that I can actually take the square root of. And notice, since there's nothing added or subtracted to the x underneath the radical, I can just go with the same numbers I used in the parent graph. So I'm going to use 1 for x, 4, and 9, because those are all numbers that I can take the square root of. So plugging in 1, square root of 1, or square root of 1 is 1, times negative 2 is going to give me a negative 2. Square root of 4 is 2. 2 times negative 2 is a negative 4. The square root of 9 is 3. 3 times negative 2 is going to give me a negative 6. And here are the points that I'm going to graph. 0, 0, 1, negative 2, 4, negative 4, and 9, negative 6. And since 0, 0 was my vertex, the graph is going to swoop out this way. Make sure you put an arrow on the end. And actually this makes sense, because notice my value of a was negative 2. The negative sign means it's going to be reflected below the x-axis, so it's going to be down here in the fourth quadrant. And that 2 out front actually makes this graph a little bit wider than the parent graph. Oh, domain and range. My domain, okay, in other words, what can x be? Well, looking at the graph, x can be 0 or any number greater than 0. So the set of all x such that x is greater than or equal to 0. And my range, in other words, what can y be? Y starts here at 0, 0 and it goes down. The set of all y such that y is less than or equal to 0. The starting points for your domain and range, the numbers that appear here, are always going to be the values of your vertex, the x and y of your vertex. And it's just really helpful to look at the graph to figure out if it's going to be a greater than or equal to or a less than or equal to. So as x is getting bigger, y is getting smaller. That's why my x is a greater than and my y is a less than. Here's a second example. Y equals the square root of x minus 4. So this is the same as saying the square root of x minus 0 minus 4. So my h is going to be 0 and my k is going to be negative 4. So my vertex, my starting point, is going to be the point 0, negative 4. So let's make our table. Oops. And again, I want to pick values of x that I can take the square root of, or pick values of x that make the stuff underneath the radical a perfect square. So again, I think I'll do 0, and since there's nothing else underneath there, 1, 4, and 9 are going to work well. So plugging those in, the square root of 0 minus 4 gives me a negative 4, and notice that is my vertex. That makes sense. Square root of 1 minus 4, square root of 1 is 1, 1 minus 4 is a negative 3. The square root of 4 is 2, 2 minus 4 is a negative 2, and the square root of 9 is 3, 3 minus 4 is a negative 1. And this gives me my points I can graph. So 0, negative 4, 1, negative 3, 4, negative 2, and 9, negative 1. My vertex is 0, negative 4, so it starts out and swoops to the right like that. Notice this makes sense, because if we go back to the information I gave you here, if k, and remember my k was negative 4, if it's a negative number, it's going to be shifted that number of units down. So notice from the parent graph, this is actually the graph y equals square root of x, shifted 4 units down. That's what this negative 4 out here is doing to it. So my domain is going to be the set of all x, such that x is greater than or equal to 0. And my range, what can y be? the set of all y such that y is, notice my starting point for my y was -4, and my y's are actually getting bigger because the graph is basically going up. So that's going to be greater than or equal to a -4. And our last example here is y equals the square root of x plus 3. Notice that's the same thing as the square root of x minus a -3 plus 0. Now why did I change that plus 3 into a minus 3? If you remember from our general form of a square root function, okay, underneath the radical I have an x minus h, so it needs to be an x minus something. But since it's a plus 3, remember plus 3 is the same as minus a -3. So -3 is going to be my h, and since there's nothing out here, k is going to be 0. My vertex is going to be the point -3, 0. And that's what I will start my table with. -3, and when x is -3, y is 0. Now, this gets a little more complicated because I need to think about values of x that are going to give me a perfect square underneath here. So let's just keep going up. If I have x as -2, that's going to give me a 1. So -2 is good. So -2 plus 3 is 1. Square root of 1 is 1. Now what if I pick -1? -1 plus 3 is a 2, and I don't want to do the square root of 2. How about 0? 0 is going to give me a 3 underneath the radical, and I don't want to do the square root of 3. How about 1? When x is 1, I have a 4 underneath there. So when x is 1, 1 plus 3 is 4. The square root of 4 is 2. So then let's see. How about 2 is going to give me a 5. 3 will give me 6. 4 will give me 7. 5 will give me 8. Actually, I think I have to go quite a bit higher to get in order to get a 9. Oh yeah, in order to get a 9 under here, I'm going to have to let my x equal 6. So when x is 6, I have the square root of 9, and y is 3. That's going to take a little bit of playing around with to figure out what values of x to choose, but please stay out of decimals. Just pick numbers that are going to give you a perfect square underneath the radical. So -3, 0. -2, 1, 1, 2, and 6, 3. There we go. Did I count right? Yeah, that looks good. And it's going to swoop off to the right like this. Okay. Let's figure out our domain and range. My domain is the set of all x such that x, and since it's going off in the positive direction, it's going to be greater than or equal to whatever the x at this point is, -3. In other words, x can be any number that's greater than or equal to -3. Notice x can't be -4. There's no part of the graph out here. And then my range, the set of all y, such that y is, and since my y's are increasing, it's going to be greater than or equal to whatever the y coordinate is here, which is 0. And notice that this graph is basically the parent graph, which started at 0, 0, actually shifted 3 units to the left. And that makes sense because that's why we have this -3 here. That means it's shifted 3 units to the left. So in order to graph a square root function, I think it's important to find what your h and your k are. Those are going to be the coordinates of your vertex, and then make a table of values and choose values of x that make the radicand, or the stuff underneath the square root sign, a perfect square, so that you'll end up with values of y that are not decimals.